at some of the questions you're expected to see tomorrow. Now, this is a general revision based on the test and generally what some of the things that you are expected to see that we've not really touched. Now, before you come to take this lecture, ensure you've taken the previous ones, the ones on the other black background I sent earlier. Please ensure you take those ones. And also, there were other lectures on the other blue background also. Ensure you take that one. All right. Now, what do you think are used for preparation of esters? What do you think is used for preparation of esters? So we have esters. What do you think we actually use for the preparation of the group of compounds called esters? Let me write this. All right. Now we say the esters, they are functional group that have the general formula of what? ROC, double bond O, O, R. All right. These are the general formulas for the ester. Now, esters are prepared by a combination of carboxylic acid and alcohol. So if you have, let's say this is a carboxylic acid reacting with an alcohol to form an ester. An ester with the elimination of what? Water molecule. And that process is what we call esterification. Is that okay? That process is what we call, my dear student, esterification. What actually happens here is that the hydrogen from here reacts with the OH of the alcohol to give us what? H2O, which is given off. Are we getting it? And that process is what we call as what? Esterification. Take note of that. The process is called esterification. All right. So esters are prepared by the combination of carboxylic acid with alcohol in a process called esterification. Is that okay? Now, for instance, something we may have, they may give you something like, let us say, this carboxylic acid, COO, CH3, COOH, plus, let us say something like this, HO, CH2, CH3. Now, what is the name of these compounds? Of course, this one here is called ethanoic acid, or you can call it acetic acid. This is a carboxylic acid, and this is called an ethanol. It's an alcohol. Now, when these two things react, the product will be an ester. So all we need to do here is remove water molecule. So this will give us CH3, COO, CH2, CH3. Remove the H and the OH from here and then combine the rest. Now, how do you call this ester? You call this side first. You agree with me that this is 1, 2 carbon, so it is ethyl. So you call this as ethyl. Then you call this other side next. This other side is 1, 2. It's also 2 carbon. It's ethane. But because it is an ester, you say ethyl ethanoate. All right. So my dear student, if I give you something like this, and I ask you to call this compound, what do you think the name of this compound would be? It's a very simple something. All right. I want this exactly coming. What do you think the name of this compound will be? First of all, we have to call this side. All right. If we call that side, if we call this side, what you have here is CH3 methyl. So this gives us methyl. Then this side is 1, 2, 3. 3 carbon, which is propane, but because it's an ester, you call it propanoate. Is that okay? So you may be given different functional group and you should be able to tell the one that is an ester. The ester functional group have this COO bond as part of it. Is that okay? The ester functional group has which bond as part of it? This COO bond as part of it. Is a derivative of carboxylic acid. That means it is gotten from carboxylic acid. Recall that carboxylic acid is what? ROCOOH. Is that okay? So when the hydrogen of carboxylic acid is replaced with arrow group, what you form is an ester. Is that understood? So that is that for esters. And I said the process is what? Esterification. So if you are asked, what two things make ester? The correct answer is what? Is acid, or you can say carboxylic acid, and alcohol. That is what makes ester. Carboxylic acid and what? Alcohol. Is that okay? Exactly. Sorry about that. Carboxylic acids and alcohol. So that is for esterification. The next thing I wish to look at now is saponification. And what is the differences between esterification and saponification? Now, in saponification, the carboxylic acid react with sodium hydroxide to form the salt of the carboxylic acid, to form something like this, and water. Is that okay? So what actually happens here? This is the acid reacting with what? Sodium hydroxide to form sodium alkanoate and water. This process is what we may term as what? This process is what we may term as saponification. And soap are manufactured by this process. Now, for saponification, the specific acid is a fatty acid. So you might be asked, when fatty acid reacts with sodium hydroxide, the product is saponification, or the making of soap is via what process? The correct answer is saponification. The making of soap is via what process? The correct answer is saponification. Is that okay? Then for margarine, we said is what? Hydrogenation. Margarine or margarine is made via what? Hydrogenation of alkene. Hydrogenation reaction of alkene. All right? Take note of that, of those important points I have just outlined. So we've talked about esterification, we've talked about saponification, we've talked about the ester functional group. Now, it is worthy of note that the ester functional group are different from the ethers. The ether have the general formula of ROR. This one here is the what? Ether. All right? This is general formula for ether. Now, how do we call ether, or how do we name them? For instance, if you have CH3 or CH3, let us assume you have something like this. This one, you can name it in the IUPAC way or the common way. Now, the common way is call what is present here, the substituent present here, and add ether to it. But because here, what you have here is a methyl group, what you have here is another methyl group, the name of this compound will become dimethyl, because there are two methyl group attached to an oxygen. So you call it dimethyl ether. Or this one here is the trivial naming of this ether. Is that okay? Or you could have it named as IUPAC nomenclature. The IUPAC nomenclature, name the shortest chain, and then the other chain will become the parent. The shortest, both of them are the same in this case, so you can name anyone. So here is CH3. So you say this is methyl, then methanoate. This is the IUPAC name, or the systematic name of this compound. All right. Now, how about you have something like this given to you? CH3, CH2O, CH3. And you were asked to name it, give the common name and the systematic name. Now, I told you for the trivial name or the common name, you name the two group attached to it in alphabetical order. So this is methyl group. This is what? From this side is ethyl because it has two carbon. This is methyl. This is ethyl. Between E and M, which one comes first? Of course, E comes first. So here it becomes, you name it as ethyl. Here it becomes ethyl methyl ether. Is that okay? Now, how about something like this? How are you going, the common name of this one now? What do you think would be the common name? Okay, this is the common name, ethyl methyl ether. Remember the common name, you name this side first. This is an ethyl group. It's not a must to name this side first. This is a methyl group. You name the one that comes first in the alphabetical order. Ethyl comes before methyl. So it becomes ethyl methyl ether. Why? If you are coming to the IUPAC nomenclature, the shortest one is named as the substituent. So which of them has the shortest ring between ethyl and methyl? Of course, this one has just one carbon. So you call this as methyl, or you call it as methoxyethane. Sorry, I made a mistake in this first one here. Methoxyethane. That is how you call it. This one here, you don't name it as methyl methanoate, but rather this is sorry about that. Methoxymethane. All right. So this is how you name it. In this IUPAC nomenclature, you name the shortest chain first, then add oxy, then name the longest chain as what? Ethane. So if I give you something like this, let us assume I give you something like this, and I ask you to name it. Common name and IUPAC. Common name. This group here is 1, 2, 3. Is propyl group. This group here, 1, 2, is ethyl group. E comes before P. So the nomenclature for this one would be something like E comes before P. So it will be ethyl propyl ether. However, if you want to name the IUPAC nomenclature, it will be the IUPAC nomenclature. Which one is shortest? Ethyl group. So that one becomes a substituent. So you call it as what? Ethoxy. Then write the propane, which is the parent, ethoxy propane. So for the IUPAC, the short one is like giving the substituent ethoxy. Then the other one is like the parent, 1, 2, 3, which the longest one is like the parent, which is in this case propane. So that is how to name the ethers. You should be able to name anyone that is given to you. Now, what is the hybridization of carbon atom in alkane? Now, alkane basically have what kind of hybridization? We said alkanes, they basically have sp3 hybridization. All right. They basically have sp3 hybridization. That is the hybridization of atoms in what? Ethane. sp3 hybridization in alkenes. While alkenes most times they have sp2, while alkynes most times have sp. There are a few exceptions anyway, but that is that. Now, dehydration of alcohol leads to. Now, I have said there's what we call elimination reaction. Now, my dear student, what is elimination reaction? Elimination reactions involve the removal of a certain group to form a double bond. It is the opposite of addition reaction. Now, if you have an alcohol, let us say this is the alcohol you have, and then you have CH, and then here is hydrogen, here is CH3. Remember in the exam it will come like this: CH3, CH bracket OH, then CH2, CH3. It's still the same thing with what we have here. All right. If this one undergoes elimination reaction, now there's what we call Zaitsev rule. There's what we call what rule? Zaitsev rule. Now the Zaitsev rule says that if this thing undergo elimination, there are two places where elimination can basically take place. Now this carbon carrying the OH is called the alpha carbon, while the other carbon adjacent it by the right and by the left, they are called beta carbon. So this is a beta carbon, this is another beta carbon. Now we can eliminate from this OH. That means we are removing the OH. But we have a choice between this beta carbon and this beta carbon. Which of them do you think we should eliminate from? Now the law states that if you want to eliminate from the beta carbon with the fewest number of hydrogen. Eliminate from the beta carbon with the what? The fewest number of what? Hydrogen. Are you getting it? So if we eliminate from the beta carbon with the fewest number of hydrogen, this one has how many hydrogen here? This one has 3 hydrogens. Why this one has how many hydrogen? 2 hydrogen. So that will give us the major product. So it means our elimination will be between this OH and this what? Hydrogen, because this one has the fewest number of hydrogen. So what would you think the product will be? When you remove this OH and H, what are you going to form? You remove water. Then if double bond will be formed here. So the product of this reaction is CH3. Here's what? C, double bond, CH, and then here's what? CH3. This here is an alkene. So dehydration of alcohol leads to the formation of alkene. Are you getting it? Dehydration of alcohol leads to the formation of alkene, depending on the kind of alkene that will be given to you tomorrow. All right. That is one thing that you should know. All right. Now, isomerism from saturated hydrocarbon. This one does not make sense. Formula of xylene. Now, there's something you guys need to know. Now, xylene is something like this. When you have 2CH3 attached to benzene ring, it's called xylene. However, there is something everybody needs to know. And I believe that is where the question came from. All right? And then we have something like this. Now, this is xylene. Now, my dear student, there's something I want every one of you to note. Now, in this structure of xylene, there's what we call auto-para position. Are you getting it? There's what we call, my dear student, auto-para position. Now, what is the auto-para position all about? If you look this structure, take this one as a reference point. Now, when the CH3 is placed adjacent That means after the CH3, this position here is an auto position. This position here is another auto position. Is that okay? This CH3, the next position, if you have two substituents, let us say you have something like this. And then I have here as X. This position here is auto to X. This position here is also auto to X. Is that okay? Now, if I have, let us say, X somewhere here, this position next is auto to S. This position is also auto to S. So when we talk about auto, it has to do with immediately after that group, the next position, if anything is attached, it is auto. Is that okay? Now, how about a situation where you have something like this? If here is X, this position here is meta to X. This position is meta to X. That means if here is X, here is auto. This place here is what? Meta. Here is another auto. This place here is what? Meta. That means after counting, like this is the position, after counting 1, 2, that second position is what? Meta. Here, 1, 2, that second position is meta. Then the position directly opposite the X is your para position. So if I have any substituent at this position, you say it is para to X. If I have it here, you say it is meta to X. If I have it here, it's octo. So in a compound like this, you can have two auto positions and you can also have two meta positions, but only one para position. So in this structure, this one now, you can see this is the reference point. This CH3 is auto to this CH3. So this structure is called autoxylene. Is that okay? This CH3 is para to this CH3. So you call this word paraxylene. Are you getting the idea now? Because of here their position. And this position here, 1, 2, is called what? Metaxylene. So this is how you should be able to distinguish between auto, para, and meta. Is that okay? Auto, para, and meta. Is that understood? Exactly. So if any question comes now under auto, if I should ask you now, let us say you have this structure. And then I have something like NH2. And then here is what? OH. And I ask you, NH2 and OH, what is the relationship between them? They are what? Auto. NH2 and let's say another NH2 here. What's the relationship between them? They are what? Para. Then this NH2 and let's say CH3 here. What is the relationship between this NH2 here and CH3? Meta. What's the relationship between this CH3 and NH2? Auto. Are you getting it now? Auto is just adjacent, it like close to it. Meta is like a step ahead. Then para is like 2 steps ahead. For instance, this CH3 here is para to this. CH3 here is meta to this. CH3 here is auto to this. CH3 here is auto to NH2. NH2 is what? Meta to what? OH. Is that understood? So that is how you should know auto, meta, and para. Now there are some groups that are auto, meta, or let's say auto, para, and meta directors. I don't believe they will bring this question for you anyway. This one I'm just writing. Now, groups like NH3, they are auto para director. That means if you have NH2, if you have NH2 here in this structure and you want to add any other substituent, the substituent can either go to the auto position or to the what? To the para position. Group like NH2, they are electron donating group. Electron what? Take it down. Electron donating, and they activate the ring. Activate the ring. They are auto para director. What we are trying to tell you is that if, let us say, you already have NH2 on top of this substituent here, on top of this compound here, and they are not telling you that, okay, carry out a reaction, which is something like electrophilic substitution reaction, which most of you don't know, but don't bother about that. And let's say you want to carry out that reaction, and that reaction will involve you adding a substituent to this ring. This NH2 is an electron donating group, and it will activate this ring so that anything that is coming in can only enter the what? Auto para direction. So electron donating group direct substituent to the auto para. While electron withdrawing group like COOH or NO2 with direct to the what? To the metal position. Is that okay? Down with direct to the what? Which of the position? Metal position. This one, they are electron withdrawing group. They deactivate the ring. Electron withdrawing, they deactivate the ring. Deactivate. While electron donating, activate. How they deactivate your account now? When they send money enter your account now. So when they donate electron to the account, it activates it. And electron donating group with direct substituent to the what? Auto para position. Is it that to the auto position or to the para position? I know to this NH, to this auto, this para. While electron withdrawing group with direct to the what? To the metal position, like COOH. So you should be able to know which one is auto, which one is what? Para. Is that understood? Exactly. So, having known that, the structure of acetylene is something like this. This is acetylene. It's something like this. Then what functional group is here? I have said before that the functional group present here is what? This is an ether. This is a very simple question. How many isomer does butane has? How many isomers does butane have? Now, let me just give you the number of isomers for the alkanes. There was a place I kept it. Let me give you the number of isomers for the alkanes. All right? Now, listen. Methane, of course, methane to propane, they don't have any isomers, so they have just one isomers. Butane has two. Butane has how many? Two. Pentane has three. Hexane has five. Heptane, you should take note of this, has nine. Octane has 18. Nonane has 19. Nonane has 35. And decane has 75. All right? And these alkanes, they undergo constitutional isomers. All right? Alkanes, they undergo what kind of isomerism? Constitutional isomerism. Alkanes undergo constitutional isomerism. Please take note. All right? It's very, very important you note all that. All right? So that is that. Let me go back to. So, like we said, this paraxylene, what do you think is the other name for paraxylene? I have this is the structure of paraxylene, right? Told you. What do you think is the other name for paraxylene? So, numbering, when you are numbering cyclic compounds like this, your numbering will start from here. Here is 1, here is 2, here is 3, here is 4, here is 5, here is 6. So another name for paraxylene is 1,4 dimethylbenzene. All right, 1,4 dimethylbenzene. How about the other ones we have here? What is another name for them? Like this one, orthoxylene. Numbering will be from here 1, 2, 3, 4, 5, 6, which is 1,2 dimethylbenzene. All right. How about meta? 1, 2, 3. 1, 3 dimethylbenzene. So you should be able to distinguish between each of these ones. Is that okay? Exactly. So that is that for this particular one. We'll see in the next one.